Since inventing the first hard rock tunnel boring machine more than 50 years ago, the Robbins Company has developed optimal designs for specific ground conditions. In 1974, Robbins pioneered the design for the first double shield tunnel boring machine, a design that allows for efficient boring in two different modes depending on the rock that is encountered. The double shield TBM can bore successfully in both competent and unstable rock. In projects where the majority of rock is unstable, a Robbins single shield TBM can be used, which operates in one mode only to efficiently bore through fractured and faulted rock. This video explains how shielded TBMs excavate hard rock with Robbins single and double shield TBMs, and reveals why they are the tool of choice for contractors excavating in both stable and faulted ground. Robbins TBMs range in diameter from 3 to over 14 meters. The front of the tunnel boring machine consists of a rotating cutter head in which disc cutters are mounted. The cutter head is supported by a main bearing. Robbins main bearings have the largest bearing to tunnel diameter ratio in the industry. This results in superior bearing life when cutting hard rock. The cutter head holds disc cutters, which consist of a shaft, bearings, seals, and a rolling hub. The disc cutters are not powered directly. As the cutter head turns, the disc cutters roll when they make contact with the rock face. The cutters roll in concentric circles. As the force on the cutter head increases, the rock beneath each cutter is crushed and fractured. Eventually, these fractures meet, and rock chips, or muck, break away from the tunnel face. This process is known as kerf cutting. Buckets in the rotating cutter head scoop up muck from the bottom of the tunnel. As the cutter head rotates, gravity pulls the muck from the buckets and deposits the excavated material onto a belt conveyor inside the main beam. The muck is then transferred to the rear of the machine for removal from the tunnel. Eventually, the disc cutters wear out. Cutters can be replaced from the front or the back of the cutter head. Double shield TBMs consist of the rotating cutter head followed by an arrangement of shields, a forward shield, a gripper shield, and a tail shield. A smaller diameter telescopic shield attached to the rear shield slides within a larger diameter telescopic shield attached to the rear shield. These shields offer protection from falling rock. In normal or double shield mode, gripper cylinders push the gripper shoes onto the tunnel walls to react the boring phases. The gripper shoes provide the reaction base for multiple propelled cylinders, which then extend to push the cutter head support and cutter head forward. As the machine advances, the telescopic shield is exposed, providing protection from the surrounding tunnel environment. The gripper shield remains stationary during boring. A segment erector is fixed to the gripper shield, allowing precast concrete tunnel lining segments to be erected while the machine is boring. The segments are erected within the safety of the tail shield. It is the double shield's ability to erect the tunnel lining simultaneously with boring that allows it to achieve such high performance rates. The completely enclosed shielded design also provides a safe working environment. If the ground becomes too weak to support the gripper shoe pressure, the machine thrust must be reacted another way. In this situation, the machine can be operated in single shield mode, the same method of operation as Robbins single shield TBMs use. Auxiliary thrust cylinders are located in the gripper shield. In single shield mode, the thrust cylinders transfer the thrust from the gripper shield to the tunnel lining. Since the thrust is transferred to the tunnel lining, it is not possible to erect the lining simultaneously while boring. In the single shield mode, tunnel boring and tunnel lining erection are sequential operations. Proper support of the rock as the TBM advances is critical to the safe construction of a tunnel heading. In addition to the tunnel lining, there are multiple options for additional ground support. Probe drilling can detect the ground conditions ahead of the TBM, such as fault zones or water. Probe drilling is typically performed to distances of 30 to 60 meters ahead of the machine. If weak ground is found, it can be pre-grouted to increase ground stability. Robbins double shield TBMs maintain the highest quality standards in the industry, resulting in rugged machines that create the longest tunnels in anything from competent to highly fractured rock. Robbins, the most trusted name in tunneling.